Hello, this is John from caveofprogramming.com. Finally, we're going to get on to looking at rvalue references in this tutorial. So here's the tutorial from last time, from the rvalue reference tutorial. I'm just going to delete this stuff here because we're not going to need it. Now, we've seen that a couple of situations where you have potential inefficiencies if compiler optimization doesn't fit in. And one of them involves return values, which are temporary values, and the other involves passing temporary values like this to a function. So in both cases, if we could identify temporary values somehow, we could handle them differently to how we handle non-temporary values and potentially introduce optimizations in our code. And that's what rvalue references are for. So an rvalue reference, we've seen, of course, it's just the old kind of reference from the old kind of C++. Let's call this L test1 or something equals test1. That's good actually. So this is pointing an L value reference at an L value. An R value looks like this, an R value reference. So we can say test, and we have a double ampersand there. And let's call this R test 1. That's maybe not a really great name, but just for illustrative purposes. So this is an rvalue reference. It's not a reference to a reference or anything like that. This double ampersand has a new meaning in this context. And what we can't do is we can't bind that, at least not directly, to an L value. So if I try to compile this now, we're going to get an error on this second line that I've just typed. So we get an error there. But we can bind rvalue references to R values. So I can, for example, bind this to test, like that. Let's try that and see if that works. So if I build this now, then it builds without an error. Or we could, for example, bind it to the return value of getTest, which is our function here that returns a test. So if I build this now, it actually works. So rvalue references actually give us a way to differentiate between temporary values and non-temporary values, or more precisely between L values and R values. So let's say, for example, we have a function up here. Let's make it void, and I'll call it check, just to give it a name. And we can give it a L value reference here. Let's say test value. We could even make this const. So that's a test reference that this function takes, an L value reference to a test object. And I'm not going to do anything with that, but I'm just going to say L value function, just so that we can see what's actually running there. And then I'm going to create another function, and we're going to make this take a R value by putting that extra ampersand in there. And usually you don't need const R value references, because as we'll see in a tutorial coming soon after this one, a lot of the value in them is that they can actually change objects or actually steal resources from objects that you no longer need, and they can only do that if they're not const. So let's say that this outputs rvalue function. So now let's try calling check. So we've got two overloaded versions of it, and if I do check and we pass in a test object like that, what we're going to get is the L value version of that function running. Whereas if we do check and we pass in an R value, for example getTest like this, or another example will be check, and I can just pass in test there. I'm not sure if my compiler will let me use this, because there might be a problem here with it being kind of ambiguous and looking like a function. Let's just try this. Well, we didn't get any warnings, so it seems like it's probably okay. Okay, so let's run this now. That's good. Yeah, so here we see that we've run the L value function. When we passed in an R value, we've run the R value overloaded version of that function that takes the R value parameter, and the same again here when we passed in another R value. So we're going to use this to move constructors and move assignment operators, which are going to prove to be a lot more efficient than copy constructors that we might otherwise have had to run. And we'll get onto that possibly in the next tutorial. So for this tutorial, it's a good idea to check this yourself, verify it works, especially since compiler support for this feature is still a little bit patchy, but I think all the major compilers have it now. So if you're using a fairly recent version of Visual C++ or GNU or whatever, then you should be able to get this working. So try writing your own overloaded function like this, taking an rvalue and an lvalue reference, and check that you can call them by supplying R values or L values appropriately. It's a good idea probably to try this first, because that's just a simpler situation. Check that works. And if you want a little challenge, try writing a function that accepts an integer and it has a R value and L value version of that function, and see what happens when you pass in ++ and that integer, or that integer ++. In other words, use the postfix and prefix operators to supply the integer values, because as we've seen, one of those is an R value and one is an X value, one is a L value. Okay, so until next time, happy coding.